Welcome back to Future Minds Gen AI Data Science podcast. I'm your host Mano and I'm excited to have you join me for our fourth episode. In our previous episode, we have explored the basics of neural networks, dived into advanced architecture like CNN, RNN, also discussed transformative power of self-attention mechanism in models like transformers. Today, we are going to build on that foundation and explore concept of unsupervised learning and its application in generative AI and data science. Let's get started. Unsupervised learning is type of machine learning where the model learns pattern from unlabeled data. Unlike supervised learning where the model is trained on dataset with input output pairs, unsupervised learning doesn't have explicit labels to guide the learning process. Instead, the model tries to find inherent structure and relationships within the data. One of the most common technique is used in unsupervised learning is clustering. Clustering algorithm groups similar data points together based on their features. A popular clustering algorithm is k-means, which partitions the data into k clusters. The algorithm assigns each data point to nearest cluster center, then iteratively update the cluster centers until convergence. K-means is widely used in customer segmentation, image compression, and anomaly detection. Another powerful unsupervised learning technique is dimensionality reduction, which aims to reduce the number of features in dataset while preserving its important structure, that is principal component analysis. PCA is popular method for this. PCA transforms the data into new set for orthogonal axis called principal component, ordered by amount of variance they explain in the data. This technique is particularly useful for visualization and noise reduction. Let's talk about one of the most exciting areas of unsupervised learning, generative model. Generative model aim to learn the underlying distribution of the data and generate new or similar samples. Two of the most prominent type of generative model are generative adversarial networks and variational autoencoders. Generative adversarial network GAN consists of two neural networks, a generator and discriminator. The generator creates fake samples while the discriminator tries to distinguish between real and fake samples. The two networks are trained together in the process that resemble game where the generator aims to fool the discriminator and the discriminator strive for improve its accuracy. The adversarial training process helps the generator produce highly realistic samples. GANs have been used to create stunningly realistic images, generate art, even design new products. For example, NVIDIA style guns can produce photorealistic images of faces that even doesn't exist, blending features from different people to create unique yet convincing portraits. GANs are also used to data augmentation, where they generate additional training data to improve the performance of machine learning models. Variational autoencoders or VAE take different approach to generate model. VAE consists of encoder and decoder. Encoder maps the input data in latent space and decoder restructures the data from these latent representations. During training, VAE optimizes both constructions accuracy and similarity of latent space distribution to prior distribution, usually Gaussian. VAE particularly useful for generating new data samples, learning disentangle representations, and performing anomaly detection. For instance, VAE can generate new images of handwritten digits by sampling from latent space, decoding them into pixel values, and they can also be used in text generation, music composition, and drug discovery. Now let's discuss the application of unsupervised learning that gaining lot of attention. Self-supervised learning. Self-supervised learning leverages the structure of data itself, create supervisory signal. This approach allows models to learn useful representation from large amount of unlabeled data, which is particularly valuable in scenarios where labeled data is scarce or expensive to obtain. One notable example of self-supervised learning is constructive learning. Contrastive learning, the model learns to differentiate between similar and dissimilar pairs of data points. For instance, in computer vision, the model might be trained to recognize that two different crops of the same image are similar while crops from different images are dissimilar. This technique has been used to achieve state of the art performance in image classification, object detection, and other tasks. Self supervised learning has also made significant strides in natural language processing. Models like BERT GPT-3 are pre trained on large corpora of text using supervised objectives such as predicting masked words or the next word in the sentence. These pre trained models can then be fine tuned on specific tasks with relatively small amounts of labeled data, achieving impressive performance across the wide range of NLP applications. The impact of supervised or self supervised learning extends beyond just generative data. These techniques are also transforming fields like anomaly detection and where models learn from normal patterns in data, identify deviations that may indicate fraud, equipment failures, and other anomalies. For example, in cybersecurity, anomaly detection algorithms can identify unusual network traffic patterns that may signal cyber attacks. Another exciting application is in the field of recommendation system. By learning the underlying structure of user behavior data, unsupervised learning algorithms can provide personalized recommendations for products, movies, and more. For instance, collaborative filtering techniques analyze user item interaction to find similar users and items, enabling the system to recommend items that similar users have liked. As we continue to explore the potential of unsupervised learning, it's important to consider the tool and framework that make this technique accessible. Libraries like scikit-learn, TensorFlow provide a wide range of tools of implementing clustering, dimensional reduction, generative models. Additionally, frameworks like PyTorch offer flexibility, ease of use, developing customs model, experimenting with new techniques. To get started with unsupervised learning, you will need a solid understanding of underlying principle and practical experience in coding and data analysis. There are plenty of online resources, tutorials, courses that can help you build these skills. Whether you are beginner or experienced practitioner, before we wrap up, let's touch on some of the challenges ethical consideration in unsupervised learning. One major challenge is the lack of label data, which makes it difficult to evaluate performance in the unsupervised model. Techniques like clustering and dimensionality reduction can be subjective. The result may vary depending on the chosen algorithm and parameters. Ethically, it is important to consider potential bias in unsupervised learning. Since these models learn from data they are given, any biases represent data can be amplified in the model output. Ensuring fairness, transparency in unsupervised learning requires careful consideration of data sources, pre-processing techniques, and evaluation method. Thank you for joining me today for Future Minds GenAI Data Science podcast. I hope you found this exploration of unsupervised learning and its application insightful and inspiring. Make sure to subscribe you don't miss any upcoming episodes where we will continue to dwell into the incredible